Hi, very good afternoon to all the students. How are you all? Are you fine? I see many of you have already been here. I can see Kubun Kyung already here. Hi, good afternoon, Kubun Kyung. And good afternoon, Chai Siu, Chun Wei, Chung Yi, Han Xiang, Han Dong, Xing Shen, and also Jing Wen, and Jui Min, Ka Xing, Ken Sing, Brenda, Lok Jing. Lok Jing has joined very early, you can see. And Mei Lin, Tiong Le, Wei Hong, Wen Yang, Wen Liang, Xu Pian, Yan Chang, Yao Ting, Yi Si, Yong Chuan. Hi, good afternoon, Yao Ting, and then Yi Yang, and then Zelim, and also Chang Hen. So good afternoon to everyone. So basically today we have 2 hours of the class. Before I start, any question you want to ask me? Related anything? Now it's already week number 7. We plan to have our test on week 9, right? Week 9. We still have 2 weeks, so don't worry. We still have time. So let me remind you that the syllabus of the midterm test will be on the performance, instruction, and then pipeline, until chapter number 4. Yeah, until chapter number 4. Yes, correct. Chapter number 4, performance, instructions, and pipeline over here. So these are the things that we will be tested until chapter 4 for our midterm test. So for tutorial, first tutorial definitely we need to cover. For first tutorial, it's about the performance and then speed up. All those we have to cover because this is related to the CLO number 3. Then we will also study the CLO number 2 instructions. So for instructions also, for tutorial 2, you also have to study. So make sure you study tutorial 2 as well. Yeah, and then you need to know the Intel instruction code. Yeah, and then tutorial 3, do we need to cover? Let me check. Yeah, we need to cover tutorial 3 because it's about pipeline. So as you can see, for the first, for the midterm test, we will be covering the CLO 2 and 3, which is the instructions and also performance, including the pipelining. Yeah. So these are the 4 chapters that we will be covering. And then all these 5 until 9, we will cover during the final exam. Of course, the chapter 1 to 4 as well. But mostly, many of the questions will become from 5 to 9. Okay. Any question you want to ask me? Related your test or related your cash not included in the test? I'm still thinking, do you want to include? If you want to include, I can include. Yeah, which one do you want to test more? I think no need, right? You want, I can test. No, Zelim say no. Okay, because I haven't come up with the exam test question yet. So I still can, no, I haven't finalized yet. Yeah, already come out, but not yet finalized. So I can still can change if you want. Okay, now, okay, so this is our test. We will plan to have our test week 9, right? Now it's already 7. Roughly Tuesday, 14 days from now. So next week, we will try to do some exercises. For your test, make sure you know how to program the Intel codes, Intel assembly language, and also pseudo codes. Yeah, pseudo codes and Intel assembly language. Now, this is for the midterm test. Yeah. There will be a few questions but length is about half of your final exam. So don't worry, it won't be too long. You will roughly take 1 hour to finish. So that's all. After that, may I know, do you have class on Tuesday afternoon? After, let's say, about week 10? Do you have class on Tuesday afternoon after 4? Week 9 or week 10 and 11 and 12, etc. Do you have a class? May I know, do you have class? No, for group 1, group 1, no class. How about the other group? Group 2, do you have class? No class for group, for me too, or RTE, no class. Okay, good. How about group 2? If no class, then I will lump all the holidays, supposedly after week 10 also. Week 10 got class or not? Chung Yi, week 10, do you have class? On week 10? After week 10, no class. Week 10 got lab. So maybe week 11, after you have done your assignment, then I will ask you to present your work during that time. So maybe you extend all the holidays sessions during the presentation. So from 4 to 6, 4 to 7, like that. Yeah. If you need, we will use all. If not, then we just let you to do your own work. Yeah. Just because holidays are supposedly we need to replace class. Yeah. So we will replace it for presentation. So thank you, Heng Dong, for your answer, and also Chong Yi and Jingwen and Yao Ting. So, okay, very good. Make sure during the midterm test, you study the Intel assembly code and also the pseudo code. And make sure you also know how to calculate the performance. For example, the speed up according to a few methods. Yeah. So we have the clock cycles methods. And also another one, we have another law, Amstar law. So these things you must know. And then the pipelining also you must know. Basically, the question will be from there. Yeah, it will be 3 or 4 questions, short questions on that. So, any question you want to ask me regarding the lab? Or any other things? Nothing, then we can start our first session of our lectures.
Dr. Hong, sorry. The test will be conducted on weeknight, Tuesday or Friday?
Tuesday, because Friday we don't have enough time.
All right.
Yeah. Yeah, okay, Chong Yi, yeah. Is that okay for you? Tuesday. If let's say you are too stressed, you let me know, maybe you change to 1 week later. Friday, I have another class after your class. So I cannot extend your time. Yeah, Tuesday, yes, I can.
All right, should be fine.
Yeah, thank you. If let's say you are too stressed, you let me know. I can extend 1 week. Yeah. Yeah. Let's say week 9 you're too stressed, then we can do week 10 if you really cannot stand already. Okay, now let's go to the lecture notes. We have already done a lot of the RAM. So today we are going to talk about the ROM. What is a ROM? When we talk about the RAM is random access memory. So when we talk about the ROM is actually read-only memory. You can only read the memory, but you could not write it. So ROM is used for storing the programs that are permanently resident, permanently stay in the computer. That means your computer must have a set of programs, assembly machine codes that it will need to have. Even though you don't install anything, your program can actually show up some message. So this has to be accomplished using ROM. Because ROM content can never disappear. And for tables of constants, for example, let's say you have you need a log table. The log table might be inside the ROM. Okay, that do not change in value once the productions of the computer is completed. So this is the ROM. This ROM is the short form for the read-only memory. So of course, for ROM also got other meaning like a registration of marriage or whatever. But in our case, in computer architecture, we are referring to the read-only memory. The ROM portion of the main memory is needed for storing an initial program called the Bootstrap Loader. So Bootstrap Loader is in charge to load your operating system, for example, your Windows, and also other software like your Androids from your phone, and also other software like Apple OS, Mac OS. All those operating systems need a Bootstrap Loader to load them. So Bootstrap Loader actually is a set of codes that can actually go to the hard disk and then grab the program, then put into the RAM. That is the function. So which is to start the computer software operating when the power is turned on. When your power is turned on, the RAM has nothing. So it cannot do anything. You will directly jump to the ROM. The ROM, then it will execute the instruction inside ROM. Then it will actually load the Windows and Android and Mac OS operating system. So read-only memory, short form is ROM. It has many types. So sometimes the ROM, even though you say it's a permanent, but it can be erased sometimes for reprogramming. Because the scientist has already made use of some current technology to make sure that the ROM can be rewritable. But these have the odd requirements, such as UV light or erasure only at the block level. So it will not, it's very odd, that the ROM can be erased and it will be used very oddly. It will not be used very frequently. Sometimes it requires special device program. For example, the processor can only read, not write. Okay, so if you want to, you have a piece of ROM. If let's say you want to program it, what you do? Let's say a piece of ROM. Yeah, for example, like this. When you learn your microprocessor, when you program it, a ROM, you need to put it under a UV light. Okay, UV light. Yeah, so only it can be erased. After erased, then you need to put it in a special equipment. Then that equipment only you put the ROM inside. Yeah, so only then you can program it. Yeah, this is how to program the ROM. So you cannot write the ROM. You can only read. Processor has no function to read to erase it because it involves the UV. UV is the ultraviolet light. So there are many types of the read-only memory. We have the many type of ROM. We have the EPROM, EEPROM. We have the custom mask ROM. This one, custom mask means you need to go to the factory. Then only the factory will generate the custom mask ROM for the computer manufacturer. And we also have the OTP, OTP ROM. Also here the flash ROM. So all of these cannot be erased by using the processor, except maybe flash can be erased. So we have many types of the ROM. So what are those meaning for the ROMs? Let us look at the ROM uses first. ROM, what's the usage? ROM is to do the permanent storage because it's non-volatile. Non-volatile means it will not disappear. Will not disappear. So a ROM will not disappear. Will not disappear. So it can also be used to done the microprogramming. Yeah, microprogramming for our computer to do the Bootstrap. Bootstrap Loader. And then it also have the library subroutine. It can carry some library subroutine, and also it can become the BIOS system programs. And also it can become you can store some functions tables. For example, you can store the sine table, cosine table, tangent table, and etc. And also it can be used as the embedded system code. For some of the embedded system, they directly use the ROM because the program is fixed already for the embedded system. What are those embedded system? It's like your washing machine. For example, let's say if your washing machine has the computerized function, so you must use the ROM because nobody want to program washing machine after they bought it, right? For example, your aircon, etc. So if they have a processor, means they will need a ROM. Okay, so because we don't want to change anything after that. Yeah, so we are going to study the first ROM. The first ROM, we call it EPROM. What is a EPROM? You don't care about this ROM because we are now talking about ROM. EP means programmable. So means electrical programmable, electrical programmable ROM. Written to only with programmer. Programmer is a machine. It's a machine that can use to program the ROM. It can be erased using ultraviolet light. So as I said, they put your ROM into a box which has the ultraviolet light for maybe half an hour. Then after that, everything inside the ROM has been erased. Then after that, they put it into a programmer and use your computer with the USB and then program it. And of course, we have some software to program it. And also, it's positive because non-volatile storage without battery. So it can the positive point is non-volatile storage without battery. You can write to it, but only with the aid of a programmer. So this programmer is a set of machines. So it's connected using a USB or any. I'm sure now we have the wireless one, but usually it will be connected with USB, and then you put the ROM inside. Yeah. So this is called the programmer. So negative point is programmer requirement. You need a machine. Then it is very expensive, and the location must be erased before writing. So you must erase this EPROM, electrical programmable. Okay, electrical programmable. Okay, programmable. Okay, electrical programmable. So to end right. Okay, so this is the electrical programmable ROM. Besides, we also have the EEP ROM. Now we have the EEP. E still stands for electrical. Sometimes electrically, okay, electrical programmable, read-only memory. And the E, what is this E? E is, what's the meaning? Erasable. Okay, erasable. It's erasable. Means it can be erased without the ultraviolet. So it's written to with either programmer or the programmer processor electrically. So the processor can also write to the EEP ROM. It's erased with either a programmer or the processor. So it's a byte to byte electrically. Okay. Sometimes you might get the message that from your handphone vendor that they want to update the BIOS. Okay, update the BIOS. So what is the meaning of updating the BIOS? If you have the EPROM, you cannot update the BIOS. If you have this EEPROM, your processor can help you to update. After updating, that it will be permanent there until you update the next time. So positive point is non-volatile and programmable as a single location at a time. But the negative point is even more expensive and only small sizes available and extremely slow write times. So it's very, very slow. So EEPROM, if your handphone or your computer has EEPROM, it's possible that you overwrite the BIOS. Okay, BIOS, you know all the computer got BIOS, right? It's your Bootstrap program, basic input-output system. We need the BIOS before we have the operating system, because the machine need to load the operating system. So we have the BIOS. When you open your computer, sometimes you need to set up the BIOS, right? So you press the F2. Sometimes you press the F1. Sometimes I press F10. Sometimes I press F12. Yeah. So this one is for your BIOS. For my computer, usually it's F2. Yeah. Sometimes it will be asking you to press delete or press insert. Depends. Actually depends on your computer BIOS. Yeah. So last time there is a virus, very, very dangerous virus appear in the world. The danger of this virus calls CIH. Yeah, CIH. If I remember correctly, it's a Chernobyl virus. This virus, once you get infected, they will override the BIOS. Let's say you have EEPROM, they will override your BIOS. What happened? Let's say if they override your BIOS, you cannot do anything until you send your computer to your computer manufacturer and ask them to reprogram all the ROM. Okay, so this is the dangers about the virus. Yeah, it's very, very dangerous, and many computers just rust out like this, and nothing can be repaired. Yeah. Besides, we also have the custom mask ROM. This custom mask means you need to create a mask. Yeah, a mask is required, but the mask is very expensive. Yeah, only when you are a computer manufacturer, you need a large volume of a single product, then only you will use the custom mask ROM. So positive is become cheaper when you manufacture more than 2,000 plus. And the components come from chip manufacturer already programmed and tested before taking out a manufacturing step. So this custom mask ROM is already programmed, then only you will install in the computer. But the negative point is the cost is very expensive if you only want to generate a few pieces. You cannot, because you need a mask. So engineer need to go and design a mask. So that cost is very, very high. It will take a few weeks or a few days to get the mask ready, just to do a mask, maybe a team of engineers. Then you use your mask to generate one ROM, then that ROM is very expensive. Yeah, this is very customly made. So the second is the software changes are costly, very costly. Let's say if you have a ROM, you cannot change. Once you have to update to your ROM data, you create a new mask. A new mask, then you have to go through a new engineering team, then the engineering team will design one more mask. And then, yeah, it's very expensive. So involve the engineers working days, right? And also the whole machine just used for you. And then you create one ROM, then it's very expensive. Maybe 10,000, 50,000, yeah, like that. So it cannot be reprogrammed. It's very, very fixed. After that, we have OTP. I know at this time, everyone is knowing this OTP on one-time password, right? When you have your banking accounts or whatever. But this is not about one-time password, but it's one-time programmable. One-time programmable ROM means you only can program one time. But to disconnect a logic 1 and turn it to 0. So everything is 1. So what you can do is to burn the logic, burn the fuses inside the ROM, it becomes the 0. You still need a programmer. Yeah. different programmer for one-time ROM. The advantage is the bad thing is written to the data is forever. The advantage is cheaper than EPROM due to cheaper packaging and more packaging options. And then you don't need to do UV. Why you don't need to do UV? Because you do also no use. It cannot be reprogrammable and standard off-the-shelf components, and you can buy it from any shop. Yeah, and then it's cheaper than the custom-made, customized ROM up to about 10,000 devices. Yeah, so this is all about this one-time programmable ROM. The disadvantage is to reprogram. Oh, sorry, this one is turning. Yeah, I don't know why it's AT here. Sorry. So please change. To reprogram, have to throw out the chip. So whenever you have programmed it, that's it. No more. Yeah, you cannot reprogram it. No chance for you to reprogram it. So they'll only be used for stable design, but it's cheap. Last one that we are going to talk today is a flash. Yeah, when we talk about flash, we say it's programmable. Yeah, it's programmable. Yeah, it's very true. So this memory are basically EEPROM, electrical, erasable, programmable, read-only memory, except that the erasure occur at the block level in order to speed up the write process. So the flash can be erased at the block level. Means you have one ROM, so it can be divided into many blocks. Once you want to erase anything, you have to erase the whole thing. Erase the whole thing. Then only you can write back. So it's non-volatile. Non-volatile means it will not disappear. It make the flash work like a fast solid state hard drive. So we might have the flash drive. Yeah. The advantage is non-volatile and higher density than both SRAM and DRAM. So when you have a flash drive, you can have higher density than SRAM and DRAM, and the information stored inside will not disappear for a reasonable time frame. Of course, when you put the magnet in nearby, then it might be affected. So this disadvantage, yeah, here again, disadvantage is the process of storing data is at the block level. If you want to change only one word, let's say you have a one, you detect that this one you want to one becomes zero, you have to erase the whole thing. So you have to copy everything outside, then you erase the whole thing, then change thing, and then copy it back. So data cell must be erased before writing data to it. So that's all for today, the ROM topic. Any question that you have before we end this lecture for these chapters? If not, then I will come up with it's a pool. Then I would like to choose ask you some question. Please answer the question. Give me 1 minute. Okay, I'm going to pose a question to you. Please select the correct answer. Which ROM is not erasable? Choose from that. Not erasable. Actually, there are two answers there. But you can choose select one. Which from is not erasable? I'll give you like 2 minutes to answer this question. We have 10 seconds. About 10 seconds. Actually, half a minute. Please answer it. You can guess any answer you want. There are two answers here. You can choose either one. Okay, I'm going to end the pool in 10 seconds. Yeah. 9, 8, 7, 5, 3, 1. Okay, I end the pool. Yeah. So let me show you the result of everyone. Basically, what are the answers? Let me show the result first. So this is the result that I got from the class. Yeah. Okay. We have the customized ROM, which is correct. Very good. There are 3 words. Okay, very good. And then we have the one-time prompt. Also correct, because it's not erasable after one time. Yeah, okay, very good. So the other can be erasable. This one flash in blocks. EP from can be but using UV. This one can be erasable using processor or any or UV. But this one is byte by byte. So nobody choose this. So very good for those who answer correctly. Okay, thank you for today. We have finished this ROM. So for your information, we still have 3 chapters at the back. But mostly these all are about the theory. There are very few calculations over there. Mostly about the theory. Because it's about the theory because we want to learn about the concept. So for today, let's see what we can do today. Later, I will continue to learn about the Intel instructions. Okay, but before that, let me introduce you to software. I think some of you haven't learned this yet, but this is a very important software, which is the electric software. Don't worry, I won't test you inside the test or exam for this electric software. But I think that this is a very good software, which is for you to actually do the IC design. Yeah, IC design. We have the electric software. You have to download this electric software. Where do you download it? You have to search electric. But that one is the other, you can download yourself. If you are interested, I just want to introduce to you this software is the electric. Yeah, it's a IC design software. It's a very important software. Yeah, I heard some question. Need install, you just need to download, and then you need the Java. Because it's written using Java, so you download this. Yeah, then after that, you can open it. Just click this. That means you can open it from here. just click. Yeah, just one file, 27 meg. Installation, you need to install the Java. Yeah, the rest, I think no need. Okay. Who asked me question? Junken, yeah. Need to install Java, yes, correct. Got lab. Okay, yeah. Need to install Java, yeah, correct. Okay, now, this is actually the electric, because I think that if you learn computer architecture, you don't know what is the principle behind to implement a computer processor or any computer parts. You don't know the basic principles, then I consider we don't know computer yet, right? So I need to introduce you to the computer. Yeah, let us open a library. And this electric software is very generous. They give us a MIP processor design, the whole processor. So if you are interested, you can actually download them and then go and see yourself. But the concept inside is very difficult because it consists of a few million transistors. So unless you are the designer, then you will not understand. Yeah. But let us see the design of a processor in case in future you work with Intel or other company, IC company, then you technologies are complementary metal oxide semiconductors. So this will be the MIPS layout. This is the IC. So you can actually, see this. Yeah. So this is actually the IC. Yeah. Yeah. So you can see that for the MIPS, for the IC, this is top of the MIPS. It has some memory address, 32 bits. This is also this 32 bits microprocessor, and memory byte enable is a 3 0 to 3 means 4 bit, and memory data is 32 bit. So 32 bit address and 32 bit data, and memory byte enable 4 bit, and then we have the memory enable, and the memory read write. Yeah, read write. Yeah. So these are all the design, and then we also have the interrupt. We have interrupt. We have 8 bits, and then we have the memory done, pitch 1, pitch 2. Yeah. So this all you have to read their design, and then this is actually the IC design, the top, and then we also have the schematic. When we go to the schematic, so these are all the schematic you might not be able to see clearly until you install yourself. Yeah. So this is the schematic. Yeah, let me open, make it bigger. So schematic means inside the schematic diagram. Yeah, let's say memory system. So we can go in and then we go to, yeah. Okay. So we can go in and then, so we can go inside the hierarchy. For example, 2, we can actually, yeah, 2, yeah, we have a lot of tools over here. So special zoom, we can zoom in, zoom out. And then we can, many things we can do. Yeah. Yeah, so these are all, yeah, all the functions that it has. So, yeah. So this, besides, we also have the layout. So the layout is over here. So, yeah. So these are 2 parts. Memory write over here. And this one you need to see yourself because for those who are interested, you can go and see all those connections. They have the wire connect from here to here, then how it connected, connect using this material. So this one, they call it, they have the material metal one, and then we have another material, Matter 1. Usually it's matter 1 here. Okay, so for those who are interested, please install. And then when you do your IC design class, then you can actually use it. Yeah, quite interesting. Yeah, now I am going to go down the level. Yeah, so this is the part. So you can see the design over here. All the pins are all the wire are here. Then I go down hierarchy. Go down the hierarchy. So after that, control 7 is to go down. So all these are the wires to connect the data path or etc. All this wire. So they connect everything so that they send the signal from one to each other. So I further go down. Yeah. So these are all the principle inside. So let me see what is inside. Yeah. So you can see these are the IC and all those are the map. Let's say this one, what is this? Matter 3. According to this one, it say matter 3. And then this one, what is this? Matter 2. We have the matter 3 at the third level. Because right now the IC, there are actually many levels. There are more than 7 levels. In these technologies, the mods they have their own process specs. So this one is matter number 2. This one is matter number 3. When we call matter means we are engineers. Because if we say it's a wire, means it's not something, not electronic engineer at least, right? So you see level 3 matter connected to the level 2 matter through this contact. Because a different level, so this is contact. Yeah. So this is actually the design inside the computer. If you become the computer designer, especially if you're dealing with layout design, so this is called the layout design. So you will be able to draw this layout. So every day you're going to see this layout every day. Then you need to perform some check. Check whether the layout is correct or not. We have a lot of check here. Design rule check. You can check. And this electric will give you some message. So that, let me pull this. No error file. Of course, no error file. That's right. Yeah. So very small one. I said we go to which one? Yeah, let me go and check some function inside. Yeah, multiplexer. Yeah, let's say you want to design a multiplexer. You can actually come into this multiplexer. Yeah, multiplexer. Then we click multiplexer. We have the schematic. This is the multiplexer schematic. 3, 1, 2, 3, 4, 5, 6, 7, 8, 8 bits. Yeah, so and then these are the design. So when you design, after you design the input output and schematic, then you can see the IC, terminal D, and also to output 8 to 8, then and then select. So select which one. Okay, so here is the layout design. If you have already learned the layout, then you can understand this layout a little bit. Okay, so don't expect too much. It's very difficult, the IC technology. So we go in and then we go and study. Go and see. You can see these are the method, and then you can go in. Let's see how to go in. Let's say I want to go in this one. What I can do. Okay, Control D. Okay, Control D. This is actually the layout design. You can see for every layout, actually there are some wire. So this is actually called polysilicon. Polysilicon is for the input. Yeah, input. Yeah, input, all the input you have to use a polysilicon. This thing are contact line. You see contact two layer. So the blue color one is actually uh, also a metal lah. Yeah. So here, and then we have the metal one. Metal one is the first layer metal, and then we have this one. Transistor is actually basically the whole section over here and here. We have the NMOS and PMOS design for this. So yeah, so you can see inside actually we have these are all the transistor, yeah, transistor over here. So when you do the IC design, then you will program this. Yeah, you have to learn your user path, and then from your digital electronics, then you design all this. You might be able to make some full adder, those circuits. So the good thing about this electric is, although it's very complex, but it gives you the whole circuit diagram for the whole computer. In case you are really very interested, then you can go and study yourself. For your information, I only know how to open and narrate a little bit only. The whole computer design need get a team of engineers to understand the whole thing. Yeah. So these are all the polysilicon metal one. And then what is this component? Yeah, the green one is the transistor pre-active, and then this NMOS, PMOS over here. So what function you implement? A multiplexer, 1x4 multiplexer. So these are all the very important things. If you need to know the data path, you go and see the data. Yeah. Let's say I go and check. Yeah, all these are very, very, very interesting. So finally, I will tell you where to download if you are interested. But this is not inside Sleepers. I just want you to go and open the MIPS processor, electric software by Steve Rubin. This is the only software which is free. Yeah, free. It's under the Steven Rubin. So this guy actually give a very free software for us to use. So you can download. Yeah. So after you download, then you can go and watch the circuit design of a computer. Yeah. Yeah, you can do timing analysis, everything. Because outside the software, for many software like Cadence software, many other software are actually very expensive. We as a normal user, we cannot afford to buy. Only those company like Intel, Huawei, they are able to buy. For us, we use electric to learn about this. So these are all the things. And there are some documentation which you can learn step by step. If you are interested. Since you are learning computer architecture, so you must know the computer actually using all these things. You see metal one, metal two, metal three, and then inside we have the poly, etc. So in between metal one, metal two, we have the contact. You have to pour in some material that will make a hole, and then pour in some materials, and it become an IC. Although it's at the nano level, because now the computer is very, very tiny already. Like 9 nano, 10 nano, 13 nano, like that. So it's very, very small. All the matter is nano, yeah. Yeah. So yeah, this is the 3D view of a computer IC. Yeah, you can actually watch. Yeah, everything is inside. So there are many examples you can download. I've downloaded everything. Yeah, downloaded everything, all the chip. Yeah, we have the many other chip. So you can download. Any question you want to ask about this software or anything before I give you 15 minutes rest? Then we will learn programming. Anyone has any problem? Need install Java, yes. If no problem, no question, then we will rest for 15 minutes. We'll come back by 3:10. 3:10 so that you can rest enough before coming back. Is that okay? Rest 15 minutes, yeah? Okay, thank you, Yao Ting. So I will close this for 15 minutes. See you later. Hi, good afternoon again. 10 minutes has passed so fast, right? It's already 3:10. So we need to come back to our class. Just now I've already searched our electric software because I have talked about to you about the RAM for SRAM and DRAM for many times, but yet you haven't seen the real design of a SRAM, right? Yeah. So all you know is actually RAM actually is 6-speed and 6T RAM, right? So, and also DRAM is actually one transistor and one capacitor. So today I'm going to show you inside this electric software about the about this circuit design of a 6T RAM. So this is a SRAM for 1 bit. Okay, SRAM for 1 bit. So basically this is a circuit design. So let me show you this is circuit design. What is this? Basically, this is the NMOS. As you can see, this is the NMOS. And we have the PMOS over here. So, yeah. So we have the NMOS, PMOS, and we have the VDD over here. The power, and also the ground over here. So we have the PMOS, NMOS, and these are the connection. Yeah, from here to here. So basically, this is the input and output. We have the control line. So what control line is this? This is basically to control whether the signal can pass through or not, right? Yeah. So this is the inverter. Two inverter over here, they connect to each other. And then here actually we have the data, 1 bit going in or going out. So basically you use a pass gate over here. These two are the pass gate NMOS. When you enable this, when you have the signal of 1, you enable this, then the data can go through. Yeah. So let me show you the label. Yeah. And I go to show you the label because if I have the label, you don't see the circuit, right? So the word is actually here. Okay. And then the bit is actually here. So if your word is enabled, so a bit can go through. So only 1 bit, you need 6 transistor, either NMOS or PMOS. Okay, you need 4 NMOS and 4, no, you need 4 NMOS and 2 PMOS. PMOS is over here. So we have the connection over here. So if you look at the input and output, basically you have the word here. This is a control bit. Yeah, when you enable it 1, then this one will go through. This is a bit and bit bar. Sorry, bit and bit going out. Yeah, bit going out, bit going back. So this is how it works. Any question about this SRAM? Are you interested? Yeah. So this is how you design the RAM, SRAM. So this is actually the outline, or sorry, the input output of the SRAM bit. And after you have designed the schematic, what you need to do, you have to convert this schematic to become the layout using layout diagram. This is the actual the actual layout that will be processed, will be manufactured inside the IC. So this is how inside the IC the materials are put inside. Yeah, using some lithography techniques, photolithography techniques. So these are actually the layout of the SRAM. Of course, in order to design this, you need to know the basic in the IC design, which you will learn during your year 4. That's why stay tuned during your year 4. Yeah, so it's a very interesting topic. Then you can actually, in the layout, so you need to label, this is the word. Yeah, this is the label over here. Then only they will do the schematic to layout matching. And then after that, you do the what check? LVS layout versus schematic check. Yeah, so you can actually check many things over here. Yeah, we have the DRC first, and then we have the LVS, etc. And so the software will help you to do a routing. Routing means you can pull wire from one place to another. Then they'll find the shortest path for you. They do not to block other transistor. So this is the PDD, and we have the bit here, like what we say, bit and bit underscore B is a output bit. Yeah. So these are all the design. Yeah. And then we see what else is inside this. Do we have other? Let's see, do we have other parts? Then we can learn together. D-cache. D-cache, let's say you have a D-cache. Then this is the layout. The cache. The cache here, this one is the layout. Scan and layout. So we go and check. Max already, yeah. Yeah. Inside, for many path inside. So you can go and watch it yourself. What else we have learned? Then we can go and see the cache controller. All those are cache RAM, cache controller. Yeah, all this you can go and study a bit yourself before we learn the IC design. Yeah, SRAM bit. SRAM bit. We already done right, SRAM bit. And then we have the SRAM array. SRAM array, you have the array of the SRAM. Yeah, so this circuit, and we have the layout design like this. We have the array. So yeah, there are many things here. So now, I just want to show you what is inside the textbook. You can see yourself inside the electric software. You will be interested to download from the Steve Rubin. So for now, we will continue to study the assembly code, Intel assembly code. So this is actually the addition function. Today we learn this addition function. How do you go to this addition? You actually jump from somewhere else. Jump from where? Addition. Yeah, you jump because you jump equal to addition. If it's equal to A, then we jump to addition. If equals to B, equal to S, then we jump to subtraction. When you jump equal, compare, if yes, then jump equal to addition, then we will run this function. Previously, I've already shown you during my WhatsApp group and etc. We have been able to use the DOS box to do it. Yeah, we have already done it. Then I've already shown you. So today, we are going to, I want you to try to write some programs so that it will be beneficial to you. Yeah, so where's my DOS box? Yeah, so this one, in case I want to use something, I just mount it, mount C with the C SSM. Yes, you see. Okay, what is the so I mount my folder ASSM, which is inside my C folder. Yeah, so I go to ASM, then I run this program because when I run this, they say this apps can't run on your PC. To find a version for your PC, check with the software publisher. Why is that happen? Because current version of the Windows that don't allow us to access to the many of the processor function for some protection or whatever reason. So in order for us to bypass this protection, we need to use a DOS box, which is this one. So we are going inside and then we go to do the dir directory. Yeah, we go to CD to the C. Okay, CD to the C, and we use this one C column, double column, then we dir, and then we try to run this program. PC. Okay, as you can see now, can I make it bigger. I cannot ask him. Okay, so now this is actually the program that I already compiled. The program that I showed you actually has been compiled. So if I type A, then they ask me to insert an addition first and enter first number. So I put 4, and then enter second number. I put 5. Then they give me your answer is 9. Yeah. So this is what is done by this assembly language. So I press enter again. They say hello, welcome again. I do subtraction. I say I put a 6 and then 3. I can get a 3. Yeah. This is the function of this software under exe. So today I'm going to show you the addition, move AX data, move DS AX, and then move DX offset message 3A. So, and then call put S. So these 4 lines are actually used to do what? Used to print out a string. Which string is message 3A? So this one, they try to print out addition. Message 3A is, I think should be addition. 3A, oh sorry, addition, enter first number. So they put enter first number. Then we call a get C, get child, get character. And then after I call the put get character, I'm able to key in 1 character. Then the character will store at AL. So I move the AL, A register low 8-bit to the BL. So after that, I subtract the BL with 0. This is about the ASCII, SSCII. So from the 0, if let's say 9, then I get a 9. After that, I move this one. I print out some other message. Yeah, I call a puts again. And then I call a get C again. I get another character. Then I get this one. So I add the BL to AL. What's the meaning of add BL AL? So I put the content. Let's say AL is 5, BL is 3. So I add the AL into the BL, meaning that I add 5 to 4 like that. 5, original 5, we have 4, then we add 5 to 4, then we get 9. Then this one, I move the BL to DL. Because when I move the BL to DL, I will be able to print this DL using the put integer function. Yeah. For your information, this program actually mostly designed by me. Yeah. So I designed it. Yeah. So don't worry. It works one. Okay. So put integer. So you call get C, and then you move BL AL and return. Yeah. Call get C and then move BL AL. Means any key, any character you type, you press, and then you will move up. And then go to the return and look again. Yeah. So any question about this addition? If no question, then I would like to give you something to do for this 20 minutes, maybe 20 to 30 minutes. So let's do a program. I want you to try this program because it will be tested during your test and also your exam for this Intel assembly language, right? Assembly, Intel, right? And Intel assembly language program, Intel X0, X6, because X0, X6, X0, X is different. X0, X0 is different. They have a different assembly language. But after that, Intel has used a similar assembly language for everything. So choose A, ask the user to key in a password. Okay. You have to print B if password equals to P, not P lah, equal to 5 lah, easier for you. Then print out welcome, welcome. Otherwise, print out imposter, stringer, stringer. Yeah, like that. Please write this program. Yeah. So I will open the Jamboard. For those who have done correctly, then you can directly post to the Jamboard. So this time I don't use the. I don't want to use the assignment that one. So that all of us can see your program. Yeah. So we have a Jamboard. I'm going to share my Jamboard. You can actually, yeah, write your program there so everyone can see, and then also show, can paste your screenshot your output. Yeah. For who has already done, you also screenshot your output and then put into the Jamboard. Yeah. I give you like 20 minutes. Yeah. So finish, then only we will discuss. Everyone please log into the Jamboard. You can open your DOS box and you can test it. Then you can I see 3 already joined in. Cannot. You can use whatever space you want. Write this type of program. Just like say you understand computer architecture, but you don't know how to write assembly language. That is wrong, right? It wouldn't be right. You have to write at least one. Yeah. So ask the user to key in a password. If password is 5, then print out welcome. Otherwise, print out stranger. So you already have my code inside. So try to do this thing. Yeah. And then post your code here and also your output here. Yeah, you can screenshot and then put here. Yeah, you screenshot, you put here, or you cut and paste, put it here. So give you like 20 minutes. Yeah. The first one will be it. So just put your answer here. Yeah. 20 minutes. It's too late already there. Okay. Yeah, let's do it. Everyone please do, yeah. And then you do and you try to run it and then show your answer over here. Yeah. I give you some time. If you have a question, you can ask me. Yeah. Can copy and paste our codes inside, then you can know how to do it. 20 minutes means 3, yeah. Until 3:50 p.m. maximum. Touching your internet is not stable, is it? Yeah, I saw him left and join few times. So first who done this, please put your answer there with your output, yeah. And you see, it's not easy to do a full password. Let's say you want to key in anything using XMP is very tough. Do many loops. You compare also, you have to do many times. So I just want to do one character so that you know the concept. Yeah, how is everyone? Can do or not? Everyone is doing? May I know anyone is doing and planning to share soon? Yeah, anyone is sharing soon? You can turn on your mic. Let me know. Let me ask. It's Poon Kiong. I always Poon Kiong because started with B. Poon Kiong have. Are you planning to share? Poon Kiong or Chai Siu or Chia? Chia, are you planning to share your answer? Chia or Chung Yi? Anyone? So Jam got answer. Oh, you sell Jam got answer. Just post only. Okay. Thank you. Thank you, Jang Hen. You saw Jam got answer? Oh, yeah, so small. How I see. Okay, thank you. Anyway, who post this? Yeah, I know. This is Jay. Okay, let me see. Okay, Jay is dreaming. Okay, is he dreaming? Thank you. If dreaming, is he dreaming? Are you the one who put this answer? Okay, very good. Finally, I get an answer. Yeah. Okay, very, very good. So this is the answer. I think everyone can join Jamboard and then look at it yourself. Model. This is what? Oh, this blue guy is who is this? Blue. Oh, many, many coming already. Yeah. Let me see who did this. May I know who did this? Let me see. No class. Oh. Anyone did this? Oh, let me check whether the answer is correct or not. Not me. Dreaming say not me. Who already done? Just let me know. Don't worry. Yeah, if correct, then me. Oh, okay, Jiang Hen, it's you. Okay, okay, you say you saw Jiang the answer is you. Okay, okay, good. Can you post? You can compile yourself. Actually, should be correct if you dare to post, right? Okay, let me see. Put the nine. You have the password, please. Yeah, correct. Okay, very good. Actually, move AX. Yeah, all this. Actually, you can actually compile this one using a gem, using a yeah. You can actually compile and run it yourself using the DOS that I have shown to you. Yeah. Let's say if I go to the SM, so I put another. Yeah, I try to open a text document. Let me see. Zhang Hen. Okay, Zhang Hen. So I put your name Zhang Hen. Dash. Okay. So we paste the code inside and that's it. Okay, very good. So after that, we go to the DOS box. How do we compile? Yeah, the day I could give you the link, right? ml.exe. Which one? Let me see the first, right? I cannot see the headshot. This will be funny. I cannot see. Hmm. Okay. I think I have to mount again. Okay. Let's say in this case, I should have to go and open again the DOS box. Let us I open double. Try to mount it. Mount C S N. A C D go to C. Now I can see this one. So I do is ml or exe illegal command ml. What I illegal command. Okay. So I need to go and check what is the thing I could show you, right? Check. We try to run this program. You see, okay. Let me see the command that we send. Okay. Computer architecture. Okay, I go and check what we did today. Okay, now okay, what we did. Okay, multi. Okay. Um, wait. We have to. Okay, let us compile first. We go to this one. Visual C plus plus. And then we go to this one. Okay, I try to use ML. Now they say got that ML. So I go to C, CSM. Okay. So now I do the ML. MF. MF then stroke C. Stroke C, that is Langton.txt. Oh, okay. No error message. Yeah, very good. And link 614. Link 14. what command I can put? And we link Duncan dot. It cannot, right? So what we have is we have to go to MSM. MS. I go to MSM and then I go and search the link file. This one is the link file that I want. So how do I call from here? Now I can link Duncan.ob. Okay, so I need a name. So if I don't want to choose a name, I just press enter. No. Yeah, so supposedly, I have this Duncan.exe. Okay, just Duncan, try to run Duncan. Yeah, now they say the program or feature cannot start or run due to incompatibility of 64-bit. So now I go to the DOS box and then I run it. I try to see this Duncan. Oh, so I have to mount again. So I have to close this. I go to the DOS box. That means there's no error, right? Well, very good. First time no error. Yeah, usually our program usually got error one. Why your one don't have? The seldom we have something which has no error one. Sure, we will face error first. So we run this /. Password space. What password? Jahan? What password you put? Jahan?
5.
5. Okay, I put 5. Welcome. Okay, welcome. Got one more L. Yeah, never mind. Duncan. What number you want to put now? Illegal one?
Whatever.
9, yeah? Stranger. Okay, very good. Thank you. Big rapport to Duncan. Very good. Yeah. So I've shown you the whole process to do the compiling. So I will do the put this into the Jamboard so that Duncan work can be proven. Correct, right? So I put at the Jamboard. Yeah, very good, Duncan. So you can now you can do it. So reload. Okay, now don't worry. Wow, you so pro. Yeah, correct. Well, one time, no problem. Let me call again. I thought it's zoom but it's Duncan. So yeah, still a few minutes. Luckily, we can get everything correct. Then everyone can refer to this when you do revision or whatever, which is a good thing. Where's the... Okay. Yeah. So I put the output here so they know it's correct. Very good. Okay, very good. Let's give a big round of applause to Jack. Okay. So still have 3 minutes. Any question you have? Yeah. Any question you have? For anyone, if let me ask who got any question. If not, then we can rest a while before. Yeah. So yeah, very good. One time can do. No error at all. Got the strict. The welcome got one more L. No, but that one is good. So okay. So very good. One time no syntax error, which is very unbelievable. Very good. So now, any question? Let me ask. I believe everyone has come at 32, right? So I just mark everyone at 10. Chai Siu, any problem? Or Chie, any problem? Chung Yi, Chun Wei, any question? No question, then no problem much. You may say, okay, so you can leave the class. Thank you very much. I hope you enjoy trying the electric or the DOS and also etc. So next time we will discuss more about theory because mostly will be theory already, virtual memory, everything. So thank you very much and bye. Thank you. So see you next coming Friday. Thank you. Bye. Yeah, thank you.